Okay. Good afternoon, all. Please concentrate here. So, in previous sessions, we have completed the first part of the second chapter. There is a processing of the plastic material. In that, we have discussed the different processing methods. Okay, for different materials, for thermoplastic material and for thermosetting plastic materials, along with the working principle. Then different types, if any. Some processes are not having the subtypes. Okay, so if there is any subtype, then we have discussed it. Then advantages, disadvantages, and application of each processing method. That part we have finished in previous session. Now, from today's session, we will start the different welding methods. How we are going to perform the joining of different plastic components. And in today's session, we are going to discuss two methods. Okay, I will first give the introduction to the how we are going to do the joining method. It's a brief classification of the joining method. This part is not included in your syllabus. You may consider it as a content beyond part, or you can consider it as a prerequisite. Okay, just the introduction to the welding of the plastic material, how we are going to carry this welding process. Okay, and in today's session we will discuss the hot gas welding and hot tool welding process, how it is used for the plastic material. Now, before starting this, now first we will go through the introductory part of the joining method. Already this part I have repeated in the introduction. Okay, this part already I have taken at the starting of this chapter. These are the some prerequisites required for understanding of the welding methods for the plastic material. You should have the knowledge related to the engineering chemistry, then the polymers in the sense, the brief classification of the plastic materials, then basic knowledge of the welding processes. Okay, and this basic knowledge you have taken in the manufacturing processes subject for your second year related to the metals. The basic working principle will be same. Okay, just we are going to change some parameters or some of your materials. Okay, then this is related to the title of this half chapter. You can say that is welding of the plastic material. Here, what we are going to do, we are going, instead of, suppose why it is necessary to do the welding. First, understand it. Suppose there sometimes it is very difficult to manufacture a large shaped component, large shaped or complex shaped component. We can manufacture it, but it is very difficult to manufacture that large shaped or complex components without any defect, and it will also take more time and more cost or more efforts. Okay, to reduce that, what we are going to do, we are manufacturing it into small pieces, and we are going to assemble it with the help of this joining methods. Okay, now here the different joining methods, the basic classification of the joining methods for the plastic materials. We have three different methods here. Okay, this is the classification of the plastic joining method. Is it visible? This classification is visible. Wait. Yeah, I have one more. This is visible. This slide is visible. Okay. Okay, please. Okay, I think this slide is visible. I have 2-3 slides. Just tell me which one is visible. This is also not visible. Okay, this is visible. Okay, I will read it for you if it is not visible. This is the chart which shows the different methods for joining of the plastic material. Here I have given classification of plastic joining methods. Now it is divided in 3 types. The method used depending on the method or principle used for the joining. Now the first classification is mechanical joining. Okay, here we are joining the 2 parts with the help of some screws. Okay, just we are joining it with the help of some fastener materials, okay, or some screws. Just we are fitting it to different parts. We are joining it with the help of some screw fitting or press fitting like this. This will be termed as mechanical joining. Okay, simply we are joining 2 parts with the help of screw fitting. Screw fit or with the application of some amount of pressure. We are not using any heat here. Okay, heat is not used here. We are not melting any raw material, or we are not adding any filler material. Just with the help of some mechanical instruments, we are joining the 2 different plastic components. This method will be termed as mechanical joining method. For example, with the help of screws, we can join the parts. Okay. Then the application of some snap fit or press fit. Okay, simply 2 different parts will be connected. Now in the second method, we are using some chemicals or some solvents to join different plastic parts. We are creating bond between these 2 plastic parts. Okay, we are joining by creating the bond. It will be considered as adhesive bonding. Adhesive means we are sticking them together. Okay, and we can use the different mediums here that will be termed as adhesive bonding. And in welding process, what we are going to do here, we are using the combination of heat, then some filler material and pressure. We are using different combinations. Okay, we will take the raw material, then we will use some torch or different mediums to melt it. Okay, then we will add some filler material, some extra material to create the bond between 2 different plastic materials. Okay, for example, you can say that hot gas welding. Hot gas welding, what we are going to do, 2 different plastic plates, we will join them. How we are going to join them? By using one torch, okay, gas torch, and one filler material. Extra material we will add in that 2 joints, and we will provide the heat and pressure. Okay. Here we are providing heat as well as some filler material and pressure. Combination may be different. Okay. And this process will be termed as the welding of the plastic material. Okay, we are joining the materials here also. Plastic material will be joined, but we are not providing the heat, filler material, and pressure. Okay, depending on the whichever medium we have used for creating that bond, it will be termed as mechanical joining method or adhesive bonding or welding processes. In welding processes, we are using the heat, filler material, and pressure. Okay, sometimes you can use only heat and filler material like this. Combination may be there, different combinations may be there. That will be termed as the welding of the plastics. Here we are having different types. Like for example, I have written here ultrasonic welding, vibration welding, heated tool welding, then hot gas welding, infrared welding. Okay, different methods will be there, and that different methods we are going to discuss in this chapter. Okay. Now, again, this welding methods are classified in 2 different types. Okay, as here you can see, whichever medium we are using to generate the heat. In the welding method of that plastics, whichever method we are going to use for generating the heat. Okay, due to that heat, that material, plastic material will become soft. Okay, before creating or before joining two different plastic materials, we have to make them soft. Okay, and for that heat is required, and depending on the medium used to create that heat, this welding process is classified in two different parts or types. You can say that the external heating welding process and internal heating welding process. Okay, is it visible? Slide is visible or not? Wait, I will check whether I have added any other slide. Is it visible? Chart is not visible here. Okay, I think this is visible for you. Instead of using the same contents are there, just different slides I have added. Okay. Now, what is the external heating? Difference between external heating and internal heating. Now, in external heating, directly we are using some external heating source, and by conduction or convection, heat is transferred to the raw material or our substrate. Okay, substrate word I will use here frequently. Substrate is nothing but the, your raw material or the plastic part that we are going to join. That I will consider as a substrate material. Okay, suppose these two are the plastic parts. I want to create bond, or I want to join these two plastic parts. Then these two plastic parts will be termed as substrate materials. Okay, if you've gone through some publications or research papers, you will find this word substrate. Substrate means, you can say, your raw plastic part, okay, on which we are going to conduct the process. Now, if to create the heat, we are using some external sources, and heat is generated by conduction. Okay, like gas torch. From conduction, heat will be generated. But sometimes what we are going to do, we are just applying the mechanical force or mechanical energy, and due to that energy, some energy is created, and that material will become soft. Okay, whenever we are applying high amount of pressure, if I apply high amount of, if I keep these two plastic materials in this position, and from top surface and bottom surface, if I apply high amount of pressure, some deformation may be there in that material. Okay, and it will become soft. This is the again a method to create the heat, and this method will be termed as internal heating. What we are going to do here, we are using some mechanical energy, and through this the heat is generated. Okay, so for example, our ultrasonic welding process or friction welding process or laser welding process, these are the types where we are using some, you can say, some indirect heating methods. Okay, directly we are not providing the heat. Some indirect heating methods are used to generate the heat and to make that plastic material or substrate soft, so that that bond will be created. Okay, according to this, these are the two types of the plastic welding processes: external heating method and internal heating method. Okay, or external heating plastic welding and internal heating welding of the plastics. Okay, this part is not in your syllabus. Just I have given some information. You can consider it as a prerequisite or content beyond syllabus part. Okay, classification of the joining methods and classification of the basic plastic welding method. Okay, now we will come to the actual part. Okay, whichever part we have discussed, the combined slide I have added here. Already we have discussed this: mechanical, adhesive, the welding, external heating and internal heating. Okay, this part is clear. This part is clear. Okay, then we will start the actual welding of the plastic materials here. Okay, two methods we will try to complete here. Okay, you can draw this chart for your reference. Please draw this. Just draw this initial part only. Plastic joining, three types, and one example you can write here. Okay, here I think I have not explained this part. This part, electromagnetic heating. This is one of the method, means how the heat is generated. I think in our metallurgy subject, we have learned that surface heat treatment processes, induction heating we have learned, induction. We have learned that last, the surface heat treatment process. In that, directly heating we are not doing. What we are doing, we are taking the raw material for our workpiece and we are winding the coil, and electric current is passed through that coil. And as we are passing the electric current through that coil, it will generate the magnetic field. And due to that magnetic field, ED currents are generated, and that ED currents will heat the workpiece. Direct heating we are not doing here. Okay, so these are the mediums. Here, by some application of some mechanical energy or mechanical force, we are making the material soft. And here we are using some different mediums like electromagnetic heating, or you can say that winding the coil and passing current through that coil. Direct contact is not there. Okay, work will be like this and material will be around it. We are passing electric current, then due to that magnetic field will be generated. Directions will be different. Okay, and due to that magnetic field, what will happen? ED currents will start flowing through the surface by surface. And to heat that workpiece, we have to just change the frequency of the alternating current. Suppose I just want to heat the top surface, frequency will be less. If I want to heat that material at the center also, then you have to increase the alternating currents frequency. Are you getting this? Means I am not directly heating the material or the substrate. I am using different methods here. That methods I have highlighted here. Here, this electromagnetic heating, you can say that, then mechanical heating, or mechanical energy and electromagnetic energy we are using to make the material soft or to generate the heat. Okay, please draw it, or you can write this classification. These are just the examples, whichever methods I have written here. This is not the classification. These are the examples for external heating. Heated tool, hot gas, then extrusion. Okay, different welding methods are there. After completing this chapter, you will able to do the classification on your own, where we have used the external heating or direct heating, and where we have used the internal heating. Okay. So these are the first methods, that is the hot gas welding of the plastic and hot tool welding of the plastic. Okay. Now, first I will take the hot gas welding, what we are going to do here. Okay. Now, whichever part I have written in the slides, you can go through that part. Okay. I will not waste time here to read these slides. I will directly explain the working principle. Same working principle and procedure you will find in these slides. Okay. Now I will come to the working principle here. Okay. Now here, if you see this diagram, this is the diagram for hot gas welding. Now at the bottom side here, these are the different joints. Okay, different joints that we can create. Now Please concentrate on this four. These are the repeated again and again. This is the single butt joint. Okay, two different plastic plates. Please concentrate here. Okay. Wait. This is one plastic plate. This is the second plastic plate. We are joining these plastic plates in this way. Okay. This is single butt joint. Okay. V shape will be there from this end to other end. Okay. Now this is the double butt joint. Are you getting this? Here at the top one V notch will be there, and at the bottom also one V notch will be there. This is double butt joint. Then this is the angle joint. Here two plates will be joined to create this angle. Okay, this is your joint. Here this will be your joint. Okay, single butt. This is the joint created or bond created will be in this area. Here at the top layer from top side in this way, and the same bond will be created from the bottom side also. Okay, are you getting this? This is single V. Okay, like this. Okay, just consider the top part from this. Okay, and now in the double butt joint, what will this like this shape at the top surface and at the bottom surface also, like this. Are you getting this? V shape. V shape will be there. Only when that bond is only at the top surface, it will be single butt joint. Okay, from one end of the plate to the other end, like this joint will be there. And if we are joining from top end and bottom end also, like this. Okay, this is the top end and bottom end, like V shape. This is visible. Huh? Wait, I will try to zoom it. So now I think this is visible. Okay, this is single butt joint. This is double butt joint. These questions are very basic questions. These questions may be asked in your interview. Okay, these are very basic questions. They may ask you this question in interview. Slide is disturbed. Okay, this is angle joint. Then fillet on a T joint. Here T shape will be there. Here you can see in angle joint, two different plates are there. This angle may be different, okay, depending on the plates, or this may be on both sides also. Then this is the T shape we have created here, T shape, and this will be joint. Okay. Now we will move to towards the actual concept. Okay. Now the hot gas welding is basically classified in two types. The first is your hand welding, and the second is the speed welding or speed nozzle welding. Now in hand welding, okay, you can see here. Please refer this diagram. This is your gas torch. This is your filler rod, filler plastic rod. As we are joining the plastic material, filler material will be plastic only. Okay, and these are the plastic plates, two plastic plates. Okay, now how the process is conducted in this hand welding process? We are holding gas torch in one hand, and in other hand the filler rod will be there, and this will be a manual process. With the one hand filler material will be provided, and with the torch I will heat it. I will heat the plastic material. Okay, here at this point I will provide the heat to the plastic material, as well as I will provide heat to this filler rod. Okay, and this raw material or this plastic material or your substrate material, it will melt, start melting, or it will become soft, and that filler material, it will also melt and it will get filled in this joint, whichever butt joint, single butt joint we have created. For example, it will fill that raw material. Okay, just I will provide simultaneously heating will be provided to the substrate and the filler rod. Okay, and we will move this torch and your filler rod will be moved in this direction from one end to the other end. Are you getting this? This is your hand welding process. Hand welding process. Okay, diagram is clearly visible. This is hand welding process. Okay, and here in disadvantages, you can say that here I have highlighted that as it is a manual process, we cannot do the rapid production, means mass production is not possible as it is a complete manual process. It is very difficult to do the automation in this process. Okay. You can do some research work on this if you are interested in doing your project work, how to do the automation of this process. Okay, some work is going on or some work may be done. You have to found that just perform some literature review and try to find out the previous work done, and then you can visualize your roadmap for your work. Okay, so this is the hand welding process. Then the nozzle welding process will be like this here. Okay, different nozzles can be used. Okay, this is the nozzle welding process. Now, what we are going to do here, some round nozzle is used here. You can see from this nozzle that gas torch will come. Now here, one point I forgot to mention, that gas torch, we are using the compressed inert gases. Okay, compressed inert gases, and whichever torch we are using, here control valves will be there to control the flow of that gas. You may ask questions how we are going to control the flow or how we are going to control the torch. One heating element will be there on the torch and one valve will be there. To that we can control its flow or ratios of that gas. And generally we are using inert gases. We are using air, nitrogen, carbon dioxide gas. These gases will be used to generate that torch or heat. Okay, whichever heat you can see here. This is the flame. It is very much similar to your oxyacetylene welding for metals. For metals, you have learned that oxyacetylene flame is generated, and with that flame, we can heat the metal, and filler rod is also heated. Simultaneously, it will fill that gap or joint will be created. Are you getting this? If any question is there, you can ask me. Now, okay, here, this is your torch. Okay, on this heating element will be there, and valve will also provided to control the gas flow. Depending on that gas flow only, you will get the flame. Similarly, in your domestic use, if you are using the gas, there will be one knob to control the intensity of that flame. Okay, whichever gas you are using in your home while cooking, knob is there. Na? Like depending on that knob, you can control the amount of heat, intensity you can control. In the same way, here, whichever torch we are using, on this torch only, valve will be provided. Valve. Okay, with that you can control the flow of the gas. Okay, and with means by controlling flow of gas and that heating element, we can control the torch or intensity of this flame. Okay, just simultaneously, what I will repeat this process again. Initially, prepare the specimen or whichever substrate material is there. You have to prepare it depending on the joint. Okay, if you want a single butt joint, then prepare the surface according to that. Some machining will be required. Then after preparing that surfaces or substrate materials, then position it on one flat plate. Okay, now I want to create bond in this way. Okay, this is my joint. Then I will start from this end. Okay, then I will use this gas torch, and this gas torch, it consists of the inert gases. Okay, compressed gases will be there, and valves will be there to control the gas flow, and heating element is there to generate the spark or that generate the flame. And after generating the flame, in one hand I will hold this torch, and in other hand I will hold that filler plastic rod, and simultaneously I will provide the heat to the substrate. This is the substrate. It will heat the substrate and this filler material also. And so just I have to move from one end to the other end, and it will fill this gap. And after providing some time for the cooling, that bond will be created, or welding of that two substrate material is completed. Okay. Now this is the hand welding process, and as it is done, we can use it for different thermoplastic material. In applications, you can write, we can join the different thermoplastic parts, and in limitations you can write, as it is a complete manual process. First point is we require skilled worker, and we cannot use it for mass production. Rate of production is very low. Then the next type is the speed welding. Here, what we are going to use, we are using the nozzle. Okay, this kind of nozzles will be there. Okay, here in speed welding, I have used this speed nozzle. Okay, now this speed nozzle, you can see here, two parts are there joined together. Okay, from this one outlet, your filler material will come out, or you can fix the filler material here, and from this we will get the your gas torch or gas flame. Okay, means we are attaching them together, and manually I can move that torch. Single torch will be there, and on that torch only that gas flame will be there, and with the help of one slot we can pour this filler material also. Due to this, what will happen? Speed of that welding will be increased. Okay, this will help us to improve the speed. Okay, here also we have shown this is the workpiece, okay, or plastic material, and here we are creating the welding. Okay, this is the butt joint table, single butt joint. This is the welding torch. This is the gas supply. Okay, heating element, and here flame will be produced. This is your consumable, means your filler rod only, filler plastic rod. Okay, this we can do the manually, but only in case of the speed welding we are using this kind of nozzle where that torch and filler material is fixed here. Okay, and we can perform the welding process with little high speed. So this is the hot gas welding of the plastics, and this is used for the thermoplastic material. Okay, now I will move towards the next type, hot tool welding process. Okay, now in this hot tool welding process, how it is conducted, I have explained that in the slides. Just I will tell you the concept. Suppose I want to join two plastic parts in material is better. So I will take this. Pen is there. I will take this. Now suppose these are the two plastic parts. I want to join these two plastic parts. Now what I will do, I will fix them first. In fixtures, I will fix this part and this part in another fixture. Two fixtures, I will fix them. Then I will take one heating element or heating tool will be there. Okay, this you can consider as a heating tool. This is the heating tool. I will heat this tool. Okay, and the temperature I have mentioned there. Heat that tool up to 200 degrees Celsius to 350 degrees Celsius, depending on the material used. Whichever plastic material we are using, depending on that, we can fix the temperature of heating of this tool. Then what I have to do, just whichever parts I have fixed. Okay, first we have fixed the substrate material. Then in the fixtures I have fixed it. Then this tool is heated. Now I will press it against this heated tool like this. Okay, what will happen? Due to this heated tool, these plastic materials will become soft. Okay, after some time I will remove this tool. This heated tool I will remove it. Then these are the soft surfaces. Now I will press this. Okay, in this way bond will be created. These two surfaces will get joined. Are you getting this? I will explain that again with the help of diagram. Okay, that part I have explained here. It consists of heating of the plastic material in the form of sheet or plate with the help of some metallic tool. Okay, and we are pressing it with the little pressure so that it will form the joint. The temperature of the heated tool is around 200 to 350 degrees Celsius. Then for heating, we can use different mediums, okay, like electric strip heaters, soldering irons, then hot plates, resistance blades. Okay. Now here, this point is very important. I am expecting this question from your side, but nobody asked this. Okay, what if that plastic material gets stick to the heated tool? It may happen. It may happen. To avoid this, we are providing the coating of polytetrafluoroethylene. Polytetrafluoroethylene or Teflon material is there. Teflon. That coating is provided on that metal tool. Okay. Due to that, what will happen when that heated tool is there and we are providing that material, sticking that plastic material to that heated metal tool, this plastic does not stick to the metal tools. Okay, coating will be provided. These questions may be asked in MCQs. Okay, tetrafluoroethylene or Teflon material we are using. Now, here just important points are there, like some parameters are there. On which parameter this process is dependent? These are the three parameters: temperature of the heated tool surface, then duration of the contact of plastic material with the tool, and pressure applied. Okay, these are the three parameters. Depending on that, your welded joint will be formed. After this, I will explain the working principle with the help of diagram. Okay, this is simple diagram. Stepwise diagram is provided. Okay, this is all. This welding process is termed as hot tool or hot plate welding process. Okay, for plastic material. Okay, these are the steps: first step, second step, third, fourth, fifth, and sixth. Okay, I will repeat it again. Now you will understand it in better way. Okay, so these are the fixtures. You can see this is the fixture, top fixture and bottom fixture. You can say that, and this is your plastic part. These are your plastic parts. We want to join these two plastic parts. Okay, these two plastic parts. What is our aim? To create the bond or to join these two plastic parts. Okay, now our first stage is to fix the plastic parts in the fixtures. These are the fixtures, and we have fixed these plastic parts. Then this is the tool, heated tool. We have to take that heated tool, and in second step, we are fixing this heated tool here. Okay, between these two plastic parts, so like this. Now the parts are pressed against the plate to melt the edges, or so that edges will become the soft. Okay, this is the third step. We are pressing it. Then remove that tool, hot tool or hot plate. We are removing it. Now, after removing this, as these edges are already softened due to the heat, we are just pressing again against that edges. We are creating the pressure. Okay, here pressure will be created, and now these two parts will get joined here. Okay, now at the last step, just you have to remove these fixtures, and this will be your final part or welded part. Okay, and this will show you the bond created or joint created. Okay, and one point is there, just you have to provide the coating of Teflon on this metal tool or your hot plate or your hot tool. Are you getting this? This is the procedure. These are the steps in hot plate welding or hot tool welding of the plastic material. Please draw this. Instead of writing, you can draw it. Okay, if you are having any difficulty, please ask me. please complete the drawing. Okay. Okay. Now, after discussing the working principle of this hot tool welding or hot plate welding, now we will discuss the types. Okay, there are two types of this hot plate welding. You can say this is the first type, and this is the second type, that is non-contact contact hot plate welding or high temperature hot plate welding. Okay, here instead of using high temperature hot plate welding, you can use the word contact hot plate welding, and the second type will be non-contact hot plate welding. Now, what is the difference between contact and non-contact hot plate welding? In contact hot plate welding, whichever heated tool is there and whichever plastic material we are going to join, direct contact will be there. Okay, that's why it will be termed as contact hot plate welding. And in non-contact hot plate welding, whichever heating element is there and your substrate material or plastic material, there will be no direct contact. Some distance will be there, 1 millimeter, ranging from 1 millimeter to 3 millimeter. Okay, and now question may be there, then how heat is created? Then it is through the radiation or convection, you can say that, or as I have already explained the concept of electromagnetic heating. In the same way that heating is done. Means what you have to understand here, in non-contact hot plate welding, there is no direct contact between the hot plate or hot tool and the plastic material. Okay, and in contact hot plate welding or high temperature hot plate welding, there will be direct contact between the hot plate and the plastic material to be joined. Okay, means this is your hot plate or hot tool. Here direct contact will be there. And in case of the your non-contact hot plate welding, tool and the plastic material are not directly coming in the, means there will be no touch of that hot plate to the material. Some gap will be there. Then heat is transferred through convection or radiation. Okay. So this is these are the two types of the hot plate welding processes. Okay. Please remember the types. Then try to remember these diagrams. With the help of these diagrams, you can explain the working principle. Okay. This is the working principle. These are the types. These are the parameters which will affect the joint. Temperature of that tool, heated tool, then duration of the contact between tool and plastic, then applied amount of the pressure. Okay. In the same way, I think I have not explained the parameters affecting the gas welding. So these are the parameters affecting the gas welding process. Okay, whichever gas torch we are using, the gases used, then your filler rod, then speed of that torch, speed of that filler material, filler rod. Okay, in manual process, speed of the torch and speed of that filler rod also, and whichever gases we are using, its ratios. Ratios means its quantity, you can say that. Okay, depending on that, we will get the quality of the joint. These are the parameters. If you are able to understand the process, you can decide the parameter on your own. Okay, how the quality of that joint should be maintained. Just ask this question: on which parameters the quality of that joint, on which parameter the quality of that joint is dependent. Just ask this question to yourself. After understanding the working principle, then whichever answers are there, that will be your process parameters. Okay. So in this way, in this today's session, we have completed two types of the weldings of the plastic method. Here, or hot gas welding, we have finished. Hot gas welding along with its two types, hand welding and speed welding. Then the hot tool welding or hot plate welding we have completed along with its two types. Okay, contact hot plate welding and non-contact hot plate welding. Okay, generally we are using this hot tool welding process and hot gas welding process for joining of the thermoplastic materials. Okay. So in this way, we have completed this part. In next session, we will move towards remaining types, that is ultrasonic welding, then infrared welding is there, friction welding is there. This part we will discuss in the next session. Okay, I will stop here. Those students who have joined through online mode, please enter your roll number in the chat box for attendance purpose. After entering your attendance, you can leave this session.